Hello, my name is David, and I'll be going over three different alternating series test problems. But with these problems, we want to say if it's absolutely converging, if it's converging conditionally, or diverging. Okay, so let's start with this one. So this problem, what we can see is that yes, it is alternating because that -1. And that power is going to alternate it between 1, 0, so between a negative and a plus, and a negative and a plus. Okay, so now let's take the absolute value. For us to know it converges absolutely, we need to take the absolute value of it. So if we take the absolute value of this, we write it like this. That's a really bad sum. K squared plus 1. I'm not going to write the absolute value signs just because I know what I did. I mean, I'm just going to do it. Okay, so now we're going to compare. Now the best thing to do is to compare it to another series. So if we compare it, I don't know, maybe let's take the highest degrees. So it's going to be k over 2 plus k over 3. Let's just use this one like this, k over 3. And if we simplified it, this 2, so it would just really be, this would really be there's 2k's right here, then 3k's right here. That's what those exponents mean. That means it would be a 1 over k. So now, I don't know if this converges or diverges, but with the p-test we can. And if we see that the power of here is actually just 1, and anytime the power is 1 in a p-test, that means it diverges. Okay, so because it diverges, we need to take the limit of it. I mean, I would compare it to the original series, but it's kind of hard to tell. So if I take the limit, as k approaches to infinity, and if I always put the one that I know, that the series that I know if it converges or diverges, in the denominator. Okay, so because I have in the denominator over the original series, I'm going to take the reciprocal, so I'm just going to do it right away. So it's going to be k3 plus k over k to the third minus 1. We take the limit, we can see that this will just be 1. Because, they both have the same exponent, so it will be 1. Okay, so that means because we got a value for it, that means this series does diverge when it's in its absolute value. So that means it's definitely not gonna be a converges absolutely. So we can take that one out of the our thoughts. But so now we need to test out and the alternating series test. So if we take the alternating series, instead of taking the absolute value, which in a way you kind of are, but you just take the f sub k. I call this the f sub k. I'm going to take the limit as k approaches to infinity, k squared plus 1 over k to the third minus 1. And then we can see, because this is bigger than this one, I mean, this is going to eventually grow faster. So yes, we can rationalize that this is actually going to equal to 0 and eventually. So now we need to compare it to this. So to another series that's a little, I guess, smaller. So if we say the k2 plus 1 is equal plus 1, and then if we add an extra 1 in there, we just have k plus 1 So sorry, yeah, k plus 1, that one will go away. And then we're going to compare it to the original. So we can rationalize because the numerators. Oh, sorry, I did something incorrect. Sorry about that. We actually put a plus 1 for every k that there is. So I'm sorry about that. So we have k plus 1 squared plus 1. They have k plus k plus 1 to the third minus 1. We're going to compare it to k squared plus 1, and then k to the third minus 1. If we think about this, even though it is not like a huge difference, that plus 1, it is a big difference because this whole thing is still being cubed. And with this cube, it's actually going to bring out, if you FOIL all of this out, we're going to actually even have an extra k in in there, and that's going to make it the denominator a lot bigger, making it smaller. So we can as we can rationalize that, yes, this function is smaller than this one, so we less than this one. So yes, that means this series right here converges conditionally. Okay, and that's it. So now let's move to another one. I'm gonna take this over here, separate it from the other problems. Okay, so now let's look at this one right here. So now we have a series inside a trig function. Um, don't get yourself confused. Like when I was learning this stuff, I got myself confused that when there was like a k inside a trig function or stuff like that. But think about the graph of the k function. Um, it alternates. It does alternate because it is an alternating series because it's gonna go from a positive to negative, and it's just gonna stay within -1 and 1. The graph is just like this. It's gonna stay between here's the actual line, and here's -1 and here's 1. So it'll be always between these numbers. So that means this is not gonna grow insane, or it's just gonna stay within its boundaries. And then this k, yes, this will grow very large. But the most important thing about this stuff is that it's gonna be between 1 and -1. And that makes it alternating. So if we take the absolute value of the alternating series, uh, the best thing to do is to probably make you could rationalize. Okay, so if I take the absolute value of this, in a way, it's like making the cosine square. Um, or just another way to think about it is, instead of thinking of like a trig function or stuff like that, try to think about it like in terms of just like one of what's in the inside. So if I take the absolute value, just do this. If I would just take this, and then in a way I'm kind of doing a comparison test, and then k over 2, and then this, oh sorry, over 3, and then this will actually be 1 over k to the second. And now it's easy for us to know if you take the absolute value of it, if it's going to converge or diverge. And then, from what we can see here is that this series, if it's greater than one with the p-test, this is going to converge. So it converges. So now let's see if it converges. Uh, no, so now, yeah, if the absolute value converges, then we don't have to do any more tests. Because if the absolute value converges, that means the entire series converges. You don't have to do anything else. I, if you do get a divergence, then yes, you have to. Because in a way, if I take the limit of this, you know, if you still want to try it out, you could do the alternating series test, and then think about a function that's like this, or just take the limit of the actual sum, and then yes, that will equal to 0. And then if you compare it uh, to one that's a little smaller, it will be smaller, and then you know so this function does converge absolutely, no matter if it's an absolute value or not. Okay, so now the last one is this one. So this one is overall it's not too bad. If I do an absolute value sign, right? But I could say, oh, I'm gonna do the alternating series test and all this stuff, right? I'm gonna start with an alternating series test instead of an absolute value or an absolute convergence test, because if I take the limit of the a sub k, which I need to do for the alternating series test, and then if I get a value, and then when I take the limit of the, I'm gonna actually get 1/2. And in a way, this is exactly doing the same thing as doing the divergence test. If I get a value that's greater than 0, if I get a value that is not 0, then yes, this series does diverge. So this series does diverge. So, overall, um, if you get like one that's like this, the first one with this is going to be a little longer, but just take it one step at a time, and then the other ones, they were quicker. Um, and like with the trig functions, just think of that, just think of their graph and how they oscillate. I know it's not like, it's not a function, but some resemble functions a lot. No, not entirely, but like it's always a good way to like think of their graphs and stuff like that. Okay, so that's it. Thank you.